In this lesson, we will be comparing properties of functions. You will need to use a combination of things you have learned in previous lessons to complete these problems. Example number 1. Which function has a greater y-intercept? So notice f of x is given to us as a quadratic in standard form, and g of x is a graph of a quadratic. If you will recall in lesson 1, this function in standard form, the c value is going to be our y-intercept. So here, this positive 3 will be our y-intercept. Recall in lesson 2 that the g of x function, the y-intercept is where it crosses the y-axis. So we can see that point here. That y-intercept is going to be at 0, 6. So in order to identify the function that has the greater y-intercept, let's write the y-intercepts of each of them. F of x has a y-intercept at 0, positive 3, because our c value is 3, and our g of x function has a y-intercept of 0, 6. So therefore g of x is going to have the greater y-intercept. Let's look at example 2. Which function has a greater minimum value? The first function is a quadratic in vertex form. So recall in lesson 2 that the minimum value is going to be the y value of the vertex. Since this is in vertex form, we could identify the vertex from lesson 1. Recall that the vertex is going to be 3, 4. It's your h value, being careful not to take the negative because that's what it needs to be in this form. So the h value and the k value makes the xy ordered pair for the vertex. Recall in lesson 2 that g of x, the vertex is going to be at 4, 2. So at 4, 2, here's the vertex, and the y value of that vertex will be your maximum or minimum value. So in this case, it's going to be our minimum because it's the lowest point on the graph. So for the first function, the minimum value is at 4. For the second function, g of x, the minimum value is at 2. So therefore, in this problem, h of x will have a greater minimum value. Let's look at example 3. Which function has the smallest rate of change in the interval 1, 3? So the first function gives you a table. To find the rate of change, we'll use the points that they identified, 1 and 3. For the function g of x, it gives us a graph. So again, we'll use the points at 1 and 3. So let's find the average rate of change for f of x. It's using the slope formula with those points. So we'll say y2, which is -6. If you want to call y2 2, then that's fine, as long as you're consistent. So this will be my y2, so -6 minus 2 over the difference of the x's. So go back for x2, 1 minus 3. I let this be my x, y pair for the second point and my x, y pair for the first point. Like I already said, it doesn't matter. You could switch those around as long as you're consistent, leaving your x's and y's together within the slope formula and x's and y together again within the slope formula. Let's calculate this rate of change. -6 minus 2 is -8. 1 minus 3 is -2. We always write our answers in simplified form, so this would be a slope of -8 divided by -2 would give us a +4 for our average rate of change in that interval. Let's do that for g of x. So at the 1, we have a point at 1, -6. And at the 3, we have a point at 3, 0. Again, it does not matter which point is your first point and which point is your second point, as long as you're consistent keeping your x's and y's together within the formula. So I'm going to take and let this be my second point. So -6 minus 0 divided by, come back and get this x number, 1 minus 3. If you need to label your points x, y, to identify which one's going to be your first and second points, please do that to help yourself set it up in the correct equation. Set it up in the equation correctly. So -6 take away 0 is going to be -6. 1 take away 3 is -2. A negative divided by negative gives us a positive, and 6 divided by 2 is 3. So it asks for the function that has the smallest rate of change in that interval. So therefore we see that g of x has the smaller rate of change.